My dear students and parents, in this video we are going to suggest a way to determine the limiting molar conductivity value of water. In the chapter Electrochemistry, in the subject Chemistry to the +2 Cbse students. You can see this fact on the board. By God's grace, my educational videos are available to 10th Cbse, +1 Cbse, +2 Cbse, NEET and IIT students in the subjects Mathematics, Physics, Chemistry, Zoology and Botany in English language. Here the question is, suggest a way to determine the limiting molar conductivity value of water. In this question, they are not asking to find the limiting molar conductivity value of water. They are simply asking to suggest a way to determine the limiting molar conductivity of water. We know that water is a weak electrolyte. What is electrolyte? Electrolyte is a substance. When this substance is dissolved in water, it breaks into, that is, it dissociates into its constituent ions, that is, cations and anions. What is strong electrolyte? Strong electrolyte is a solution or solute. This solution or solute completely or almost completely ionizes or dissociates into its constituent cations and anions. What is weak electrolyte? Weak electrolyte is also a solution or solute. In this case, the solution or solute does not completely ionize, does not completely dissociate into its constituent ions, that is, cations and anions. That is, in the case of weak electrolyte, the solution or solute partially dissociates, partially ionizes into its constituent ions. We have to find the limiting molar conductivity of water applying the Cole-Rauch law of independent migration of ions. Why should we select the Cole-Rauch law of independent migration of ions in order to determine the limiting molar conductivity of a weak electrolyte? We know that weak electrolytes such as acetic acid have lower degree of dissociation at higher concentration. Note the word, at the higher concentration. When we add more and more water in the weak electrolyte, that is, at infinite dilution, the concentration of the electrolytic solution becomes zero. When the concentration becomes zero, the electrolyte dissociates completely. That is, the degree of dissociation equal to 1. Note the point. We already told that the weak electrolytes have the lower degree of dissociation at higher concentration. Here we have made the concentration to 0. So at this lower concentration, the electrolyte dissociates completely. In this lower concentration, the conductivity of the solution becomes very low. So, the conductivity of the solution cannot be measured accurately in this low concentration. For that reason, we are following the Kohlrausch law of independent migration of ions. In the question, no other information is given other than the statement that suggests a way to determine the limiting molar conductivity of the water. So, we have to think, how can we get the water? We are well aware that when the acid combines with the base, we will get salt and water. So, let us take an acid, that is hydrochloric acid, HCl. HCl is a gas. When it is dissolved in water, it becomes the acid, that is hydrochloric acid. It is going to combine with the base sodium hydroxide. So the acid combines with the base, that is sodium hydroxide, to form the salt. Which salt? The sodium chloride salt and water. See the equation. HCl is the acid, sodium hydroxide is base, sodium chloride is salt, H2O is water. So, from this equation, we can get the equation for the water, that is H2O. Then what is the equation for water? If we bring sodium chloride from left side to right side, it will become as minus sodium chloride, that is NaCl. What is the Kohlrausch law of independent migration of ions? The law states that the limiting molar conductivity, that is lambda m naught of an electrolyte, can be represented as the sum of the limiting molar conductivity of the cations and the limiting molar conductivity of the anions of that electrolyte. It means that if we add the limiting molar conductivity, that is lambda m naught of the cations, and the limiting molar conductivity, that is lambda m naught of the anions, we will get the limiting molar conductivity of the electrolyte. So we can write this equation applying the Kohlrausch law of independent migration of ions. That is limiting molar conductivity of water equal to limiting molar conductivity of HCl plus limiting molar conductivity of sodium hydroxide minus the limiting molar conductivity of sodium chloride. This is the way to determine the limiting molar conductivity value of water. It is not asked to determine the limiting molar conductivity value of water. But we can easily find the limiting molar conductivity of the water applying the Kohlrausch law of independent migration of ions. How can we determine? That is limiting molar conductivity of H2O equal to the limiting molar conductivity of HCl can be written as limiting molar conductivity of H plus plus limiting molar conductivity of Cl minus. Similarly, the limiting molar conductivity of sodium hydroxide, that is base, can be written as limiting molar conductivity of Na plus limiting molar conductivity of OH minus. Likewise, we can also write the limiting molar conductivity of sodium chloride as limiting molar conductivity of Na plus limiting molar conductivity of Cl minus. The Kohlrausch examined limiting molar conductivity for a number of strong electrolytes. We can get the information for the limiting molar conductivity of the cations and the anions from the table given. If you see the table, you can understand that What are the limiting molar conductivity value of cations and the anions? My dear students, if this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel. If you want to get all information contained in this chapter, I appeal to the students to see all my videos.